Hi, I'm Lakshmi Yatham. I'm the co-chair of ACUMEN, an e-learning program on cognition. And in today's module, we're going to talk about neurobiology of cognition in bipolar disorder. The three things that we want to focus on in today's module include what are the neurobiological mechanisms that underlie cognitive deficits in people with bipolar disorder? Are there tools that we can use to investigate these neurobiological mechanisms? And finally, are there treatments that can specifically target these neurobiological abnormalities in people with bipolar disorder? To talk to us all about this, I have my good friend and colleague, Dr. Jin Mali. Jin, welcome to the show.
Hi, Lakshmi. Thank you for having me.
So Jin Mali is a professor of psychiatry at the University of Sydney in Sydney, Australia. So Jin, let's start with a very basic question, and that is, what types of cognitive deficits do people with bipolar disorder have?
Well, that's not really a very basic question, as you know. It's quite complicated. Neurocognition means different things to different people. I won't go into great detail regarding that, but for our purposes, I like to think of three areas that are impacted, particularly in bipolar disorder. Primarily attention, declarative memory, and executive function. And those are broad areas in themselves to some extent, but they're clearly deficits in bipolar disorder in each of those domains.
So I guess my next question is, as we know, bipolar disorder patients have the well intervals, and also there are times when they have symptoms, the mood symptoms, depression and manic symptoms. So the question is, those deficits that you talked about, are they present when they're well or when they're symptomatic? Can you talk a bit more about that?
So I think that this is what makes bipolar disorder both interesting but also really complicated to research. And as you know, long-term treatment of these patients means that you also have medication effects. So that's something we could also add as a particular layer to. But going back to your question around episodicity and the fact that you've got these clear episodes of depression and mania, and I see that as really exacerbating most of the deficits that are there or exaggerating them to the point that you can see them. So this is obviously a great place to be able to investigate and look at them, but they're distorted. They're not necessarily reflecting what's happening in between episodes. And there's a model there that one group of researchers have put forward, which I think is quite useful. It has its own limitations, and that's of hot and cold cognition. So this idea that you have cognitive deficits that are there all the time, and they're cold, that's to say they're hardwired in one way or another into brain function, as opposed to those that are hot, that are perhaps related to the state, the mood state or the emotional state. And so there's another way of breaking down the cognitive framework.
People with bipolar disorder, even when they're not symptomatic, you're saying that they have these cognitive deficits, and those tend to get exacerbated when they're symptomatic.
Absolutely. And I think the issue with the euthymic state when they're well is that maybe some of the deficits are not perceptible unless they're tested for. And also people adapt. So people compromise and adjust. So spontaneous reporting of those deficits may be not happening. So patients may not be reporting them. It's only when they see themselves as becoming unwell that they report them.
So I guess the million-dollar question is, what causes these cognitive deficits in people with bipolar disorder?
Well, I think we have to then go back to defining the deficits in the first place, and then also looking at what are the possible pathways that lead to those. Now, I think we have to dial back a little bit in terms of the cognitive deficits to be able to answer that question properly. So going back to, let's say, declarative memory, that's quite a complex process in itself. You've got the encoding of memories and then the storage of memories. And those are two separate processes. And just to be absolutely clear, this is explicit memory. This is the memory that you and I or everyone else has around events or things that happen, particularly with a personal significance. It's autobiographical memory. It's what we remember as ourselves, as opposed to procedural memory, which is things like riding a bike or knowing how to tie your shoelaces. Those are things we know of, but we don't necessarily have to recall them. Clearly the two are linked, and what we first try to learn, we pass on into our procedural memory. But it's the declarative aspects that seem to be impacted in a disease like bipolar disorder. And so we have to be able to test that and understand what is it that is causing this particular problem. Now, one way of identifying a cause is to look at where it is happening in the brain. So where is it localized? And that opens up another Pandora's box in terms of brain function. You and I know in terms of our research and our field over the past 25 years, we've moved from this concept of localization of brain function to networks. And then now from networks to whole brain function, and possibilities that we hadn't envisaged at all 20, 30 years ago in terms of how the brain functions in terms of higher cognitive functions. So that is a problem when we try to identify deficits that have been identified in research maybe 2 decades ago. They don't map onto the networks and the understanding we have of the brain at present. But coming back to what may be causing it, there's a whole range of causes of the disease itself, and no doubt some of those impact the neural structure, the architecture of the brain.
So do we actually know, I mean, you talked about 3 different types of cognitive deficits in people with bipolar disorder, and you started talking about declarative memory. Is there particular area of the brain, and it sounds like from what you're saying that may not be the case, maybe it's the connections. So do we know what areas or what connections that might actually account for the set of impairments that we see in declarative memory in people with bipolar disorder?
We don't know for sure, but I think there are clearly good candidates. And the one I would talk about most, perhaps, or I think is the prime suspect, is the hippocampus. We know there are structural changes in the hippocampus, particularly with depression, and bipolar disorder is predominantly a depressive disorder. So even though we make a distinguish it from major depression, it is essentially depression with occasional manic episodes. And so the hippocampus is a key structure, and already we know that the volume changes, but that's quite a crude measure. You know, in even the subfields that are being measured within the hippocampus, we see changes there. But again, we're really talking about large structures when we're looking at neuronal integrity or synaptic integrity. That's on a different level altogether. So what does it mean when you see a change in volume? From an imaging perspective, there could be all sorts of artifacts, and the changes may not be meaningful in terms of neural structure. But I think there's a consensus now that definitely there is a deficit there. But the hippocampus is really interesting because it's a nidus for connections in the emotional brain. And so any kind of change could be underpinning changes in networks, as you were saying. Linkages, for example, with the amygdala, the insula, the medial prefrontal cortex. These are really important. And I think it's a combination of the two. I think we'll find there are structural changes, but they perhaps are later. They're the sorts of things that, as I was talking about earlier, in terms of cold cognition, occur as the illness becomes embedded within the brain. But the early changes may just be functional. We may not see structural changes there. The new technologies, such as connectivity, may be the earliest changes that we actually are able to detect.
So you're saying that somehow hippocampus might be linked to these deficits potentially, and in the early stages of the bipolar illness, even though we might see cognitive changes, we may not see any structural changes within hippocampus. And even if we do see some structural changes later on in the disease, it may be hippocampus itself or some of the connections that the hippocampus has with other areas of the brain that might account for some of the declarative memory and those types of deficits that we see in bipolar disorder.
Absolutely. And I think that the other complication is that we're talking about episodes. So it flares up, the illness becomes more pronounced, those deficits may be more evident, and then there are compensatory mechanisms that the brain is also trying to repair. So how much of that reparative process occurs and covers up whatever change did occur? So those are really, really complex questions to untangle, and I don't think we're at that point yet in terms of understanding longitudinally what happens to the brain structure, what happens to brain function, how do networks function normally, let alone within the context of an illness, and then compensatory mechanisms.
Okay, so we can talk about some of the tools that one might use to investigate some of those mechanisms. But before we go there, you also identified 2 other types of deficits, the attention and also executive function deficits as well. Now, what do we know about the brain abnormalities that are linked to those 2 types of deficits?
So starting with executive functioning, I mean, I think I mentioned that there's reasoning, problem solving, decision making, and we know that patients with bipolar disorder, particularly when they're unwell, have deficits in these areas. But interestingly, also when they're euthymic, they seem to be compromised in these same processes. The nuance there is that a lot of the patients who are tested do have medications on board. And so when you're talking about more subtle and sophisticated deficits, then medication can play a role. But in terms of the processes that are involved, clearly medial prefrontal cortex, dorsolateral prefrontal cortex, these structures are critical in decision making and in reasoning, and those seem to be compromised. So the imaging studies are finding that there are changes in patients with bipolar disorder that are linked to these particular areas, and also these areas when they form part of networks. Now, the nature of the deficits is really interesting, I think, in this regard. It may be different to the changes we've been talking about within the hippocampus, where we might see structural change and we might see functional change. Here, I think we might also see changes within the actual neuronal axons, so the tracts, the fibers that connect different parts of the brain. Here, for example, if you've got demyelination of certain areas, then those parts of the brain can't talk to each other. Now, that's a very important deficit to be aware of and be able to target if we have certain specific treatments for that. And those types of problems early on, you can imagine, would be causing problems in integration of networks within the brain that ultimately lead to problems with decision making.
Okay. So you talked about the prefrontal cortex being the sort of a main area that might account for some of the deficits in executive functioning, either the structure itself or some of the connections that it has with other parts of the brain, perhaps through white matter tracts and so on and so forth. What about attention? Is there a particular part of the brain that might be abnormal, that might account for the attention processing speed types of abnormalities that we see in bipolar patients?
So traditionally, attention has been gravitating towards structures such as the thalamus, the caudate, and the nuclei within the brain. But I think everyone working in the field understands that really none of the tests that we administer are possible without attention. So attention is the most fundamental component. So to actually cleave that apart from other aspects is quite difficult. And the very simple motoric tests don't really test attention in the way patients complain of attentional deficits. And so you can enhance your attention by focusing, and so you have effortful attention and automatic attention, but both seem to be impaired to some extent in bipolar disorder. Trying to localize that or find a network within the brain is quite difficult, and I don't think we have a good answer for where in the brain that attentional deficit, particularly in bipolar disorder, might be occurring.
Okay, so it sounds like we need to do more work. But let's think about the abnormalities present during the euthymic period when bipolar patients are well, and you said that they're there, but they tend to be worse when they're symptomatic. And you talked about neurobiological underpinnings of these deficits. The question is, are those neurobiological underpinnings, are they the same when they're euthymic versus when they're symptomatic? Because, during symptomatic periods, they get worse, right? So how does one explain that worsening? Do we know?
So I think you're asking a question really to say, how does bipolar disorder work or come about? What is the etiology? That's the big question. And we obviously don't know that completely as yet. But the kind of mechanisms that are probably playing a role are inflammation within the brain, glucocorticoid hypothesis within the brain, the neurotransmitter hypotheses within the brain. These are all competing hypotheses, but they may also be all giving a component or contributing a component to the pathophysiology, depending on subtypes of bipolar disorder. One question we really haven't fathomed as yet is, are there different types of illnesses that we're talking about that all look like bipolar disorder? And that's a real problem, and a clear likelihood that there are subtypes depending on when the illness starts. Now, if that's the case, then the pathophysiology will vary, because there may be deficits that are unique to an illness that starts in adolescence versus adulthood, and the nature of the deficits will be very different. And that again, talks to the kind of mechanisms that might underpin neurocognitive deficits that you find later on in life when the illness is full blown. In terms of whether you actually are just exaggerating from the illness when it's euthymic, and I'm talking about illness being there all the time, to flare-ups of depression or mania, versus whether it is a cold cognitive deficit, That we don't have a clear understanding of. There's certainly no deficits that we can say are uniquely one or the other at present, largely because this model is relatively new, the understanding of this process is relatively new, and longitudinal studies are the only way to tease that out. So many people have tried cross-sectionally to compare people with depression, say, versus euthymia, but that doesn't have the sensitivity. What's really needed is following people through those various phases and seeing those changes and anchoring it to specific biomarkers.
Okay. Well, this might be actually a good time to talk about the tools, because it sounds like it's a fairly complex issue. And the question is, what tools do we have at our disposal to investigate these complex neurobiological processes that might underlie cognitive deficits that we see in people with bipolar disorder?
So I might also use this opportunity to talk a little bit about the distinction between pathophysiology, as we traditionally, in terms of our training, used to think about molecular biology and changes in cellular physiology and so on, versus the new kind of cognitive neuroscience, which is functional, to say changes in neural networks talking to each other. This is really exciting. I mean, this really relates to brain imaging and where it's going. My personal view is that I think imaging will find deficits which are functional and don't have a cellular basis. That's to say, there are deficits in how the brain works, how the mind works, and that's what patients complain of when they have subtle deficits, particularly as you were talking about when they have flare-ups of depression or mania. They may not necessarily be imprinted within the brain in terms of having receptor changes, say, or discernible changes in structure. They may just be purely functional changes within how the neural networks are processing information at that particular time.
So what do we use? What kind of tools are available to investigate those neural networks?
So this is research only. I don't think clinicians actually have access to that. So I think fMRI at the moment is the key tool that is quite useful in understanding those types of processes. But year in, year out, it's developing. I think that's what's really exciting about that, our understanding of how to analyze what is essentially the same information that we acquire is quite exciting. So, for example, when we look at the brain, we can challenge it, we can give it a task, we can ask it to respond to a particular stimulus, and that exaggerates a particular response within the brain. However, more latterly, what's been interesting is looking at the resting brain. So when the brain is supposedly not engaging in a task, how does it naturally function? What are its resting function correlates between regions and networks? And that's actually quite illustrative of what's happening when people are reasonably well, but otherwise not engaging. So to give you a more specific example, in terms of our attention to internal stimuli versus external stimuli, or wanting to distance memories that are painful to us, these are processes that are taking place within the resting brain where we try to engage or disengage from certain bits of information. Now, we are able to detect that, but only at a group level. So we can't do that at an individual level. So these tools are exciting. They're giving us insights into the type of functional changes that occur. They're clearly different, or being able to differentiate people with bipolar disorder from healthy, but not at an individual level. The other problem we have with these tools is these findings, as I said, they may not have a neural imprint in terms of something structural. So what are the prognostic implications of this? We don't know that as yet.
If we can use these tools to distinguish people with the bipolar disorder at a group level, but not at an individual level, the question is that something to do with the sensitivity or lack of sensitivity of the tools that we have? I mean, I guess the question is, as we look into the future, will we ever get to a stage where the technology is going to help us to unravel these kinds of mysteries?
So this goes into, sometimes people sort of say, well, it comes down to beliefs. I don't think so. I think we can see the trend already. If we look at research over the past 25 years in imaging, we are definitely advancing towards being able to do this on an individual level. It is a technical question. Can we get a sufficient signal to noise? So noise is the background which interferes with the information that you're interested in, and we're already enhancing that. So we're able to identify changes at a much greater sensitivity than we were a decade ago. And I think another decade, yes, we might be at a stage where 1 or 2 people is all we need to get the same kind of signal to noise ratio that we have at present. And so it's a matter of time. I think technology is advancing. That will then be our tool it'll still be probabilistic. And what I mean by that is you or I sitting in a surgery, seeing someone, we'll take a history, we'll assess them, we'll do some clinical cognitive testing as well. We might do some bedside testing, we might ask us general questions. In addition to that, we might do a brain scan, a sophisticated one, targeted at certain functions. We then put all of that information into our own clinical algorithm to determine what to do. It won't be a standalone test. And I don't think any tests that we use in medicine actually are. They always come back to decision making. And I think we're often setting the bar too high for psychiatry, that somehow we're going to be able to pick out a test and say, that's bipolar. I don't think that's what we're really striving for. What we're striving for is informed decision making, and that definitely will happen.
Okay, so fMRI is one of the tools, and it might get more sophisticated in the future. Are there other tools that we can use to look at the cognitive deficits?
So I think just finishing off the imaging side, there are other spin-offs. So the structural imaging is doing the same, I should say. We won't discuss that in great detail, but same with spectroscopy as well, which looks at the chemical makeup of the brain. So imaging is huge. So I've just spoken about functional MRI, but structural and proton spectroscopy and other types of imaging all will help. So I think that's a very promising area. In addition to that, the bedside testing has become much more sophisticated with computers. So 20, 30 years ago, all we had was paper pen tests, and as I spoke about earlier, attention being a primary deficit, actually getting people to engage or motivated was difficult. Now with computer tests, you can actually be testing memory almost automatically. That engagement is not required to the same extent, and people are stimulated to a greater extent whilst doing the tests, and standardization and reliability of those tests is much greater. We also have large data banks to compare to what is normal and what's not in certain tests. So those things will also help, and already there are a number of batteries that are used in certain terms of research. Those tests that become more specific over time are what we will be able to inculcate into our clinical practice alongside imaging, alongside clinical appraisal.
You talked about people with bipolar disorder having cognitive deficits. And you talked to the types of deficits, you talked about some of the tools that we could use to investigate. Now the question is, when do these cognitive deficits begin? Because as we look at the evolution of the course of bipolar, it goes through different stages, right? So do you think that these deficits are present at the disease onset or maybe even before that, or what do you think?
So that's a really interesting question, because I think patients are probably, in retrospect, aware of the deficits in cognition much earlier than, say, activity changes or changes in mood or changes in other biorhythms within their body, because the variance is so great in those anyway, so sleep dysfunction or appetite dysfunction, say. But when you're working and you're using higher cognitive processes, even a subtle change will throw you off. So I think people will be able to pick those much earlier. And so they're probably early markers, but they're not being picked up because people aren't attuned to that, and clinicians aren't tuned to that. We don't even ask about it. Many clinicians wouldn't think this is an early warning sign, say, or something that is probably a primary sign. But in terms of, is it an early marker of the disease or illness, that's not clear, because it's a higher function. It probably is downstream in terms of impact. So if, let's say, we were to hypothesize there is a demyelination of a particular tract that leads to a cognitive deficit, you'd imagine that prior to that taking hold, there'll be other consequences that the person might experience. So you might get emotional variance, you might get changes in sleep dysfunction, but we may not be able to detect those. So when you're asking what actually occurs first, it's more to do with us actually seeing it at the surface than it is to what causes it. So we're constantly struggling with knowing where a problem might occur and then how it meanders to the surface and expresses itself clinically. And if it takes a longer path, it seems to be a later symptom, when actually it might be an earlier symptom that's just taken a lot longer to come to the fore.
So here is an interesting question, and I've asked this question to one of our other guests that spoke about cognitive issues in people with schizophrenia, because we know that cognitive deficits are present in people that are at high risk for developing psychosis. So the question is, if some of these deficits are present in people that eventually develop bipolar, would targeting those cognitive deficits through whatever treatments we might use, whether it's cognitive remediation or pharmacological treatments, do you think that might alter the evolution or the trajectory of the illness itself? It's highly speculative, I know, but what do we know about this, do you think?
Look, I think that opens up a lot of other questions, to be frank, because firstly, any intervention, unless it's very, very targeted, and thus far I would argue that we have no medications or psychological treatments or even physical treatments that are that targeted. And by that I mean there are always sequelae or side effects. You'd have to be very confident that you're not causing a problem as much as rectifying one. And so I would be skeptical that we would be able to intervene very, very early. I think at some point or another, when you have, as I was saying, this probabilistic approach, and you're fairly confident that this is likely now to prognosticate that this person is going to get bipolar disorder, then surely, yes, at that point I would say you want to intervene, and you'd probably want to intervene with something that's low risk, so something like a psychological intervention. Now, the question there would be then, well, why not offer that psychological intervention if it's already enhancing your capabilities more broadly? So you could say adolescents in general would benefit from better emotion regulation skills, learning a little bit more about how to focus, how to manage their planning and reasoning, and enhancing those capabilities regardless. So it could actually be a general measure that's implemented more broadly, but embedded within that there is a benefit for this particular subpopulation. So you don't necessarily even need to identify the bipolar population to be able to treat them. You may be doing that generally. So a good example of that is caries in teeth. We don't identify specific people who need fluoride or ask them to paste use a certain type of toothpaste. It's just given to everyone because it's known that most people will benefit from that. Actually, some people may not, but that doesn't matter. It's no harm to them. So it's that sort of risk-benefit ratio you have to work out. So I think, yes, we want to intervene early, but it has to be done judiciously.
Well, what about people with an established diagnosis of bipolar? Because we talked about in those people, they have these deficits, and we talked about some of the neurobiological alterations, whether it's in the hippocampus or prefrontal or whatever. The question is, are there treatments that can target those things, and if so, is there a way to correct those deficits and thereby improve cognitive functioning, do you think?
Yes. Look, I think this is a really exciting area, again, because a lot of investment has gone into developing psychological programs, and also emerging are medications that enhance cognition. Particularly, we were talking about attention, we're talking about memory, we're talking about problem solving, decision making. All of these seem to be impacted. And so we want to be able to research this area and be able to offer those treatments. The problem is, are these long-term solutions? And I think that's still an open question. We don't know, either for psychological treatments or for pharmacological treatments, whether the changes are sustained. Certainly in the short term, there are many things that can be done to enhance your memory, to enhance your attention, not least of which is adaptation in terms of your work environment, so actually just reducing distractions, for example. And there's also research showing that by rehearsing certain things and certain tasks, your cognition can be improved, which is not a surprise. That's how we learn stuff. So there is capacity to improve. Question is, does that overcome the problem? And is it targeted enough to prevent the underlying pathophysiology of the illness eventuating in further downstream effects? And that we don't know as yet. But I'm certainly a strong believer of psychological interventions and pharmacological interventions in the future being able to target cognition within bipolar disorder and enhancing cognition. Whether we do it at the population level or whether we do it individually, that's the open question.
Okay, so it sounds like we do need to do more work looking at the effects of both psychological and pharmacological interventions. What about other things like lifestyle changes, for example? Would that have any impact, do you think? Exercise, things like that.
So I think that's been really interesting in certainly our careers. We've all known exercise is important, and we've I think, intuitively known that for a very long time. It's healthy, eating healthy, sleeping healthy, exercising, and so on. But the research has shown very nicely that exercise has a very powerful antidepressant effect. And it's just not the clinical impact, it's actually the neural basis of this. The fact that it changes brain-derived neurotrophic factor within the brain, for example, the fact that it's neuroprotective on cells that we know are vulnerable to insult in illnesses such as depression and bipolar disorder, those changes are really exciting. To be able to actually give our patients the story that exercise protects your brain directly in terms of neurogenesis and enhances neuroplasticity, and that it's going to protect against possible development of depression, or further episodes of it at least, it is extremely powerful. And certainly in studies, we've seen that it's as effective as most antidepressants. So that's a really exciting development. I think the problem is it has been hijacked a little bit in terms of the exercise regime. I mean, trying to work out what's the optimum type of exercise, and also the primary problem of having the motivation to exercise, which I think we all, even at a personal level, suffer from, is the biggest obstacle. But as a treatment, lifestyle change is enormously powerful. And I think that's something that we should be investing more in, trying to understand the physiology of it and how it links to the illness.
So we've covered a lot of things in this session. We talked about the different types of cognitive deficits. We talked about some of the neurobiological mechanisms that might underlie these types of deficits, and some of the tools that we might use to investigate, and some of the interventions and how they might change these neurobiological pathways. I guess the question to you is that what would you say are the key take-home messages for our clinicians from this conversation?
So, if I were talking to my colleagues, I would be saying, look, I only want you to remember these handful of things. Firstly, in bipolar disorder, do recognize that there are cognitive deficits, ask about them, and particularly about memory and the person's events and their life and their autobiographical memory. You need to explore that to understand what are the changes that are occurring in this person's life. Alongside that, maybe also explore decision-making and problem-solving. They're not going to necessarily declare that or spontaneously open up and express those problems. The second is that there are promising tools on the horizon. Some are already here. It's a matter of time before they become more widely available, more affordable, and more specific, such as imaging. And so we will be able to put that in alongside the armamentarium that we already have, which is obviously clinical experience, which is excellent. And then finally, treatments are also emerging, both pharmacological and psychological, and already lifestyle change is already here.
Well, thanks very much, Jin, and thank you for being on this program.
Thanks, Lakshmi.